Hello. Today we're going to talk about something called Eratosthenes Sieve. Eratosthenes was a Greek mathematician who came up with this sieve idea, and if you think of a sieve, it means a lot of different things. It could be used for baking, it could be used to strain vegetables or other things. Anyways, what a sieve is something with a lot of holes in it that allows some things through and it doesn't let other things through. And what Eratosthenes did was he created his sieve to capture prime numbers. And we're going to get into what prime numbers are very shortly. But first, before that, we are going to do a little background on what factors and multiples are. The definition of a factor is a number or numbers that can be multiplied to make another number. That answer is called a product. So for example, if I have, let's say, the number 6, the factors of 6 would be 1, 6, 2, and 3. They're the factors of 6 because I can multiply 2 times 3 to get 6, and I can multiply 1 times 6 to get 6. 1 and that number are always going to be factors of each other because any number times 1 will give you that exact same number. And that's really important to remember as we move on into the discussion of prime and composite numbers. But to start out, this is what a factor is. A multiple is a bit different from a factor in that a multiple is a number that can be made by multiplying by a certain number. If we take 6 for example, I know that 6 is pretty much equal to 6 times 1. If I wanted to find out what 6 times 2 is, again multiplication is just repeated addition. 6 times 2 is 12. If I continue that pattern, my next multiple of 6 is going to be 18, 24, 30, 36, and basically continuing to add 6 to get that next number each time. Another good way to remember what a multiple is to think of skip counting, just by skipping up by that number each time as you go. So that is pretty much what a multiple is. The other important concepts that we need to talk about are prime and composite numbers. A prime number is a number that has exactly two factors, 1 and itself. What that means is that the only way to get that product is to multiply 1 by that number. And that number must divide evenly as well, which means you can't use fractions or decimals to get that number. Composite numbers are numbers that have more than two factors. So if we go back and look at our example with the number 6, we knew that 6 equals 6 times 1. And 6 also equals 2 times 3. So the factors of 6, like we said, were 1, 2, 3, and 6, which makes 6 a composite number. And when we start working on our sieve, we are going to see what the prime numbers are pretty quickly. So in front of you right now, you should have a hundreds chart that looks pretty close to what you see up on the screen. So what we're going to start to do is identify those prime numbers from 1 to 100. The first thing we need to do is cross out the number 1 on our sieve. 1 is actually not a prime number or a composite number because 1 only has one factor itself. 1 times 1 is 1, and that's all you can do with it. So we have to remove it from the sieve. Keep in mind that 1 is a factor of every other number as well. The next number on our chart is 2, and 2 is a prime number. So what we are going to do right now is we are going to take a yellow pencil or marker, and we are going to get rid of all of the multiples of 2. So what I'm going to do is I'm going to draw a line through the 2. And then if I skip count 1, 2, I can get rid of the 4. And if I skip count again by 2, I would get rid of the 6. And if continue that pattern, you should notice that I'm going to be highlighting with the yellow any numbers that end in 2, 4, 6, 8, or 0, or any even numbers. So I'm going to use a little bit of magic right now and get rid of all those. So you can see that I have highlighted all the multiples of 2 with that yellow highlighter and or pencil crayon or anything yellow you might happen to have. What I am going to do right now is I'm going to identify my next prime number. So I'm going to move over 1 in the hundreds chart and identify 3 as prime. And I know 3 is prime again because it only has 2 factors, 1 and itself, or 1 times 3. So what I'm going to do now is I'm going to get my red pen or marker out, and I'm going to skip count to find my multiples of 3. So 1, 2, 3, 6 is a multiple of 3. Skip counting again. 1, 2, 3. 9 is also a multiple of 3, as is 12, 15, 18, 21, 24, 27, and 30. So again, I'm going to ensure that all of my multiples of 3 are highlighted with that red diagonal. So now I'm going to look at the next number after 3 and determine if it's prime. The next number is 4. 4 is not prime. 1 times 4 is 4, and 2 times 2 is 4. But if I move on to the next number, which is 5, 5 is prime. The only numbers I can multiply together to get 5 are 5 times 1. That would divide evenly. So now what I'm going to do is use a green, and I am going to get rid of all of the multiples of 5 on my chart because they are now factors of 5. So if I look at this number 5 and skip count over, if I look at that number and skip count over, try not to move the chart, sorry, 1, 2, 3, 4, 5, I would get 10. So I get rid of the 5 and I get rid of the 10. These are all multiples of 5, and I can pretty much eliminate any number ending in 5 or 0 because they are all multiples of 5 now. If I continue along on my sieve, I'll notice that 6 is composite. 2 times 3 are factors of 6. They multiply to give me that number. If I look at the next one, which is 7, 7 is prime. Only 7 times 1 gives me 7. So what I'm going to do now is use a blue diagonal in the opposite direction of the red, and I am going to remove all of the multiples of 7. So 14, 21, and again skip counting over, 1, 2, 3, 4, 5, 6, 7, eliminates 28, and 35, and 42, and 49, and 1, 2, 3, 4, 5, 6, 7, 56, and 63, and 70, and 77, and 84, and 91, and 98. Those are all multiples of 7, meaning that they have 7 as a factor. So if you look at that top row, you're going to notice that there are now no more primes in the first row. And if we have done everything the way that we're supposed to do it, all of the remaining numbers are prime. And again, the best way to check to determine if they're prime is to divide some of these numbers by various factors, 2, 3, 4, 5, 6, 7, 8, 9. And if they divide evenly, then we would have a composite number. But I do believe that the sieve is foolproof. All of the numbers that have no colors on them are prime numbers. So you can see there all the prime numbers from 1 to 100. And these will come in handy in the next couple weeks in math class, especially in grades 7 and 8. So hold on to this sheet, keep it as a reference. It's really good to help you find the factors of various numbers, the multiples of various numbers, as well as those prime and composite numbers. Okay, thanks a lot. See you later.